Okay, good evening, ladies and gentlemen. Thank you for everyone that is joining. We're going to give it just a couple of minutes for everyone to join. This is strange. We actually have no one here.
Well, there's three people that have already written, four now, five. There's five people who've six, and Scott's just said he can see us and hear us.
Oh, wonderful. There we go. Okay, now I'm getting it all. Okay, great. Perfect. Okay, welcome everyone. That's great to see everyone joining. Okay, we'll just wait a little bit longer to let everyone join. Very excited about this webinar and this presentation. We put a lot of work into it. Got a lot of really fascinating insights and facts to present. Hilary's just got such a wealth of information to contribute. So really excited about this. This is going to be great. I see. Yeah, we've got about a quarter of the registrants attending already. I see they're coming through all the time, as you see. Great. So just so that you understand the dynamics, Hilary's going to be the main presenter. Hilary is he's the technical director of soil biology in the UK, and he's been a soil or turf agronomist for most of his career, most of his professional career, and he's top of the game as far as soil biology goes and understanding how to use soil biology to the benefits of Turf Manager. This is such an insightful presentation. It's really amazing. Been going through it for the last couple of weeks, just fine tweaking it. I think you've got something really lovely install. So I think, what do we think? We'll wait another 2 minutes just to make sure everyone's attended, and then we can just get right into it. We also have Carlos. Carlos is he manages the distribution of macroorganics in the southern European countries.
Hi guys. Hi everybody. Nice to have you here.
Perfect. And he can also keep an eye on some of the chats and just contribute like that. Right. I think we're good to go. Hilary, I'm going to pass over to you. Please give yourself a little intro, and I think you can just take it away.
Good afternoon, everybody. Thank you for those that have watched the previous two webinars. That would help you a lot in understanding today's webinar. But at the same time, I make no apology that this is going to be quite difficult, and there will be quite a bit of recapitulation in order to help you remember the main two objectives today, which are understanding fully SAR, systemic SAR and ISR, getting a full understanding of these working mechanisms in the plant. And as we all know, you can never visit a site too often. And what I'm trying to do today is to use association through the slides to help you remember what we discuss. But for those that haven't seen the first and second webinars, I would encourage you to do that, because that will help you understand today. Thank you, Luke. Right, here's one of my favorite slides ever. This is the most ideal situation that you can find, and I make no apology for using this slide again, because this just explains and shows you what we need to create to get the best out of our soils, to get the best out of our turf. And what this slide is showing you is the start of what we're going to spend a little bit of time on, and that's carbon capture. The way that plants can sequester carbon and return it to the soil. And in this slide, you'll see references to oxygen. Return, Luke, please. We could go back. In this slide, you'll see the references to oxygen. And you all know that the co-sponsor of today is OxyTurf. So you can see for yourself the role that oxygen plays in keeping your soil stable and making sure there's a natural progression. Thank you, Luke. And this is an amazing slide, because this one slide has got such a story to it. If you get a chance to just look carefully at it, and you'll see again, it's all about carbon capture. It's all about microbes and the role that they play in capturing carbon. And it's all about the breakdown of complex compounds like lignin and cellulose, but mostly lignin. And you're going to gain some startling facts today about the way lignase is broken down and what it provides to the soil system. Thank you, Luke. Right, carbon. We're going to be addressing this in its entirety as much as we can today. And we all know that carbon is essential for life. We know that even your own body consists of carbon. And later we'll be dealing with cycling, and you'll see the role that carbon plays in that, in terms of providing nutrition. And of course, the effect of carbon on cell structure is quite well known. And here we have some beautiful slides depicting exactly what goes on as plants capture carbon out of the atmosphere and sequester it into the soils. And what you'll see here is all things which are also promoted by OxyTurf. You'll see OxyTurf, if you look at what's referred to here, you'll see OxyTurf playing a strong role in promoting it. Thank you, Luke. Now, with biology, we know that the strength of biology comes from biodiversity. And we're going to look at different ways of improving the biodiversity. And we'll touch on compost teas and the such like. We'll also touch on the introduction of microbes. But obviously, the best way to do it is to promote what is there. But then again, we have to make sure what is in the soil, what is in the root zone, is healthy. Thank you, Luke. And yes, I've put this on for a bit of a laugh. Obviously, this is not how we make compost tea now. But if you were making a nettle tea or one of those extracts, you could actually do this. But I'm sure this slide will stick in your memory and help you to remember and understand what we're trying to do as we extract from a proper compost tea. When we get a dedicated compost prepared specifically for compost tea, and then we know what we're extracting. But yes, these kind of things are done in small holdings and allotments, and people get surprisingly good results. Thank you, Luke. Now we start with the first slide, an introduction to systemic acquired resistance, SAR. Now, SAR is a long distance signaling mechanism. Just watching the arrows and watching the points, you'll see how the signaling is transferred through the plant. And this signaling provides broad spectrum and long-lasting resistance, okay, to secondary infections throughout the plant. So systemic acquired resistance, SAR, is the whole plant resistance response that occurs following an earlier localized exposure to a pathogen. So yes, we will be coming back to this, and this has been done deliberately because we didn't just want to give you a compact teaching on SAR and ISR, but we want to show you through the course of this webinar the factors affecting it, so that you can gradually get into the idea and following what we're all about. Thank you, Luke. This slide is probably well known to a lot of people. It's been shown in many presentations on soil biology, put together by Elaine Ingham, who's running some incredibly good webinars herself at the moment, but all about agriculture and farming. But this gives us a beautiful idea of exactly what is happening in the soil, in the rhizosphere, in the root zone, and down the bottom you'll read about the different trophic levels. Now, these are the levels at which certain functions take place. So we've got photosynthesis starting in the plant. We've got root exudates. We've got organic matter being degraded. And Luke's got some incredible information to give you about this. I can give you a little introduction to it by telling you to look out for when Luke talks about the breaking down of lignin into peroxidases. So when he starts talking about that, if you could pay a lot of attention, and this will help you understand how by the reduction of thatch, when we use white rot fungi, Luke, could you mute, please? When you use white rot fungi, known as phanerochetes fungi, how they can break down lignin. And could you go back, Luke? When you use white rot fungi, the phanerochete fungi range, how they can break down organic matter. And there you see them in the second trophic. So each level, we've got a higher level of microbe. And as we know, microbes are involved in a constant battle. They're always warring with each other and invariably eating each other. And we'll learn a little bit more about that when we look at nutrient cycling in subsequent slides. But what we want to bring your attention to now is the Mycorrhizae fungi. And this is a fungi that lives in symbiosis with the roots. Thank you, Luke. And here we've got some graphics of Mycorrhizae fungi. Again, I want to use pictures to stimulate association and increase your awareness. I would believe that everybody is aware of Mycorrhizae fungi, but unfortunately, not everybody is applying it. And if you think that there are seed companies that actually sell seed with Mycorrhizae, and there's lots of other biological companies that sell Mycorrhizae, and still it's not used by everybody. The Mycorrhizae that we want to consider are arbuscular Mycorrhizae, And it's a symbiont fungus that penetrates the cortical cells of the roots of a vascular plant, forming arbuscles. And the one that we work with mostly is the Mycorrhizae, which forms an association with grasses. Thank you, Luke. And there you have it. There you have the mycorrhizal vesicles inside the colonized root cells. And yes, they've used a bit of dye to identify them, but that's just so for you to see the appearance. And we all know that mycorrhizae contributes a systemic acquired resistance to the plants. And this photo clearly indicates how it supports growth and health. And we know that mycorrhizae is also incredibly effective in utilizing water and food, especially phosphorus, well known for its making of phosphorus available to the plant, so much so that even in soils that normally hang on to their phosphorus, the mycorrhizae can make that available to the plant. And we all know that living in symbiosis, the plant, the mycorrhizae attaches itself to the roots and extends the whole root system. And that's where it gets its name from. Mycorrhizae actually stands for extended root system. Thank you, Luke. And just a further, example of roots. And you might say, oh, why am I showing a corn plant? Because a corn plant is an adapted grass, so it's quite practical to use it as an example. Thank you, Luke. Now we come to what I addressed earlier as probably the most important part of today's seminar, along with the SAR and the ISR, is the establishment of soil organic matter. That is what we're all about at Soil Biology, and hence our partnership with OxyTurf and Macroorganics just fits in so beautifully, because we're all about taking the A horizon and turning that into soil organic matter. That is what we're all about. And we have products that break down thatch, that break down lignin, and as I said, you'll hear from Luke what an amazing contribution that makes, because at the time you are producing a very, very weak hydrogen peroxide, a very, very weak peroxidase. And that's what we want to use to help us break down the thatch, along with the white rot fungi that I spoke about earlier, the phanerochaete fungi, and you'll see that it all comes together as we put the different products. Slide 15, Luke. Right, soil organic matter is what we're all about, because as we increase the soil organic matter in the rhizosphere, in the root zone, we are doing all of these. We are stirring up the biology, we're giving the biology energy, we're creating a reservoir of nutrients. Because as we degrade thatch, we're producing nutrients that are then available to the plant and to the biology. In the physical sense, we are improving soil structure, water retention. In the chemical sense, we are improving cation exchange capacity. And if you go to webinar 1, you'll learn all about that. But most importantly, we are lowering the pH. And this is so important for the function of fungi in the root zone. Thank you, Luke.
Just to interject for a little moment, on the right-hand side of your screen, you have a chat box. It's where a number of you said hello. At any point, I'm going to be keeping my eye on this. And at any point, if you have a question that you want to raise or anything to contribute, please type it in there. And we absolutely welcome that. The more interaction, the better. It's really good if you can only take in so much without giving back. So it's really good to get questions so that we can discuss and make sure that you all are on the same page and understand. So feel free to drop a question, and then when it's appropriate and when there's some time, then we can discuss it. We're definitely going to have time at the end for a Q&A. It might be that it's best to just hold out to the end, but in the interim, please go ahead, just so you don't forget your question. Just type in your question, and then we'll get to it either at the end or when it's appropriate during the webinar.
Thank you, Luke. Continuing with our story on carbon. Carbon is a nutrient store, as I said earlier. Increasing cationic exchange capacity, and some very interesting facts and data here. Carbon hangs on to positively charged nutrients, cations, and just bear in mind for our later discussion that even ammonium, NH4 plus, is a very, very weak cation, and if you've got a high carbon content, that will be held, and we all know that that is very useful to promote your microbial life. And there's an interesting stat. For every 1% of soil organic matter, there is an increase by approximately 1 millicube per 100 mil, and that's the way we measure the CEC. So the more thatch you degrade, the less fertilizer you use. And that's what we're all about. We're all about reducing inputs, especially nitrogen, which can soften and weaken your plant, as you'll see in the summary this afternoon, later this afternoon. Thank you, Luke. Here is a wonderful graphic. You probably won't be able to take it all in, but if you start from the bottom, and that's dealing with the first stage of your microbial population. So that's your first stage that we saw on the soil food web slide, and you'll see that the bacteria play an amazing role, especially in their numbers. If you think that this is 1 cubic meter of soil, and then obviously as you climb the ladder, you'll be hosting less critters, less organisms. But just look at the protozoa, one of my absolute favorite, and we'll be touching on them a little bit later in terms of carbon cycling, because their numbers are easy to remember, and to help you, as I said earlier, just to remember some information and have association to remember these things. Thank you, Luke. My bacteria, as we saw, they are more bountiful than anything else. They are microscopic, and they say that there's as many as 1 billion bacteria per teaspoon of soil. And I think you can believe that, because they are microscopic and they multiply quickly, and they are an amazing source of cycling in the soil system. And I was going to mention it later in another slide, but I think it's practical to mention it now. There are a number of companies that are now producing biological fungicides, where they've isolated and identified bacteria as as a means of reducing disease. So in other words, there are now registered biological fungicides utilizing bacteria. And that just shows you how effective these little critters are. And because of their massive numbers that we saw in the previous slide, they're also an amazing food source for the rest of the microorganisms that they share the soil system with. And whatever they eat, they excrete. And as I said earlier, they excrete NH4, ammonium, and this is a very, very useful way of carrying nitrogen in the root zone so that it doesn't leach out easily because it's retained in their bodies. And we then have beautiful solubilization continuing, and this way there's always a source of nitrogen. Thank you, Luke. Then we come to fungi, probably easier to identify and to see. Again, these are multi-celled organisms that usually grow as long strands of thread called hyphae. And what's very interesting and what we utilize, as I explained earlier, is that we utilize the fact that they consume complex carbon compounds, one of which is thatch or plant organic matter, as we prefer to call it, plant organic matter. So fungi are decomposers, they're nutrient cyclers, they build up the soil structure, and they're actually plant protectors. And there are companies that are actually producing fungi now, like the bacteria, like the biological fungicides, the bacteriological fungicides. I know it sounds a little bit like an oxymoron, but that is how complex these microorganisms are, that people are in a position now, that scientists are in a position now to utilize them. And plant protectors, that would fit very closely into how you could describe mycorrhizae that we looked at earlier in detail. And mycorrhizae plays a major role in systemic acquired resistance. So there it is, it's out there. Mycorrhizae fungi is probably the most researched fungi in the world. I'm happy to announce that in 2009, Dr. Alan Gange and a team of scientists put out a paper, 1999, Alan Gange, who's now Professor Alan Gange, put out a scientific paper which entailed about 9 years of research and proved the worth of mycorrhizae. So everything on this slide is in fact happening right now. And as I said, Luke's going to give you some startling information just now about the breaking down of lignin and what that provides. Thank you, Luke. Now we come to my favorite, Protozoa. And this is a beautiful, beautiful slide. It says 3 different types there because there's 2 unique amoeba. But Protozoa, I just love them. They're one of my favorite critters. And we're not going to give away any trade secrets today, but those people that would like to work with compostees and work with them effectively, I can turn Protozoa into your best and favorite friend. And I've proved it time and time again, especially in assisting people on their approaches, on their golf course approaches, applying a Protozoa mix, which brings the approaches on and without any chemical fertilizer at all. So, and it costs you pennies, absolute pennies. And obviously everybody's heard about the shortage of urea in the country. and the potential for prices to go up. So here we have a critter who works so hard. He works so hard for you, and you can actually produce them for pennies, as I said. And what I really like about them is their cycling. They really reproduce large amounts of NH4 ammonium. Thank you, Luke. Now we come to nematodes, and this is an amazing graphic. If you just look at the mouth parts where A, B, C, D, and E are, that helps you identify them. I regularly look at nematodes through microscopes in various golf course managers' offices. Just a little bit of dye, and it helps you identify them. And these critters are just absolutely incredible because they're about the same diameter as a root, and they work their way through soil, creating porosity. They are great for controlling. They're great for controlling predatory nematodes and root feeding nematodes. Sorry, they're great for controlling root feeding nematodes. And if you get the balance right, which you can do with introduction of them, if you get the balance right, then you'll never, or you should never, have any problems from nematodes unless there's been an undue stress factor that has come in, which has in fact unsettled the balance of the nematodes themselves. And as I promised, Luke, thank you, we're now going to look at nutrient cycling and the sorry, so we've got some more. I'm ahead of myself. We've got some more slides of nematodes. Again, look at the mouth parts, and you'll see a predatory nematode literally swallowing a root feeder. You'll see a parasitic nematode that's got a long stylet. That's the pink. In the pink, you've got a parasitic nematode. And if you look at the head on the left, you'll see it's got a stylet, which goes in and parasitizes the insect or the nematode that it's devouring. And then you've got the big whale-type creature in the green, the bacterial feeding nematode, which moves around and feeds off bacteria, obviously. And of course, as it swallows up all these bacteria, it's providing lots and lots of NH4 ammonium. And then we've got in the bottom right in blue, we've got the fungal feeding nematode. So this is the one that's feeding on fungi, and hopefully it's bringing balance into the soil system. Thank you, Luke. If we could go to the next slide, which I said is the start of the nutrient cycling. When a microbe dies, its body decomposes. When a microbe is consumed by a higher trophic level predator, waste products are excreted from the predator. And as we said, that NH4 can be turned into ammonia. So the ammonium can be turned into ammonia, and that in turn can be turned into nitrite, and that in turn can be turned into nitrate. And then that becomes a beautiful food source for the plant. And that's all done through bacteria. So the nutrient cycling starts right with the bacteria in the converting of the ammonium all the way to nitrate. And we all know that in moist conditions, in very damp conditions, a plant can actually even take up NH4 on its directly. It doesn't happen often, but when it's in that situation where there is flooding and it has to make use of nutrient to survive, it can adapt and take up NH4 directly. And now we come to my real favorite slide.
Hilary,
yeah.
We've just got a question from David regarding plant parasitic nematodes. He's just asked, can you introduce nematodes that will predate the PPN?
Yes, definitely. Definitely, yeah. We are a supplier for Bionema, so we have 4 different species of nematodes. That's not in this presentation today because time would not have allowed it, and I was looking for more disease control today, and yes, insect control through nematodes is possible, yes, and we are doing it. All right, as I said, protozoa. So let's just get a full understanding of this, have this pictured in your head, and then you'll understand forever how nutrient cycling by protozoa works. So in the body of a protozoa, there are 30 carbon. The percentage is 30 carbon to 1 nitrogen. That is what a protozoa needs to survive. So in order to get those 30 carbons, a protozoa has to gobble up 6 bacteria. Now, bacteria have a ratio of 5 carbon to 1 nitrogen. That is what their body consists of. All right? So in that process, as they consume those 6 bacteria, they have a whole 5 parts of ammonium available. And that's what we call nutrient cycling. And remember, that is going on in the soil. Remember our graphic with the protozoa. Remember our graphic with the protozoa, with the bacteria right at the base in their billions, and then the fungi, and then the protozoa, and then the rest of the critters in their high volumes as well. And this battle is going on all the time in the soil. So what we are physically doing here is we are harnessing their energy, the energy that they are producing by living and eating and living off each other, and by what they are excreting. And it's that ammonium which we turn into nutrition. If you send your soil analyses to a good biological lab, they can measure the amount of bacteria, fungi, protozoa, nematode in the soil, and they can actually calculate what that soil can produce in terms of nitrogen. So there's an amazing saving, and it's nitrogen which is held within the bodies of the microbes, so there is no leaching occurring. Thank you, Luke. Right, now we start getting into the real nitty-gritty, and we're going to start here with the introduction now of gram-positive bacteria. Okay, and what we're trying to achieve here is plant growth promoting rhizobacteria, known as PGPRs. And these colonize the plant root area and improve soil health. These are all products now that are registered and certified. So there's no snake juice here, and this is the progress that has been made so quickly with, as I said earlier, with a number of biological fungicides that have been produced as well. But what we're doing here is we're looking for tough residual bacteria, and we'll just mention the Bacillus amyloliquefaciens is considered a root colonizing biocontrol bacterium and is used to fight some plant root pathogens. Now, what we are doing is we are combining this with OxyTurf, and Luke will be taking over in a couple of seconds, and as I said, he'll be giving you some incredible information which I will then build upon a little bit later. Thank you, Luke. Sorry, Luke. I just want to mention why the plant growth promoting rhizobacteria are so important is that they are very hardy, they are very tough, and they can work even at very low temperatures. We've had amazing results even under snow with them in conjunction with OxyTurf, and I think we found a way to make OxyTurf practical through the whole of winter. Thank you, Luke. Luke, you're on mute.
Oh, thank you. Super. Right, in the next 3 slides, I'm going to be talking about OxyTurf and its combination with kelp. And what we've been over the years really discovering about what its intrinsic value really is, and how it's just such a wonderful contribution to your portfolio of applications in your turf management program. So just this was done. The pictures that you see now, this is done at the Photo Golf Course in Ireland, but there are numerous such cases, and the basic idea is that we are oxygenating the soil with OxyTurf. OxyTurf is it's a plant-based product. It has a small percentage of peroxide, hydrogen peroxide. It has a large percentage of peroxidase, which is an enzyme, which I'll talk a little bit more about in a moment. And the combination of plant extracts really formulates this amazing tool to over a period of time generate more oxygen over a slow releasing period, and feeding the aerobic bacteria in the soil profile, which of course is the predominant fuel for organic metabolism. And along with that, it's also an incredible sort of cleaning mechanism, and sort of a profile profile cleaning is probably the best way of sort of describing it. As general features, improvement in the soil oxygenation and percolation is, of course, its predominant feature. As a consequence, you can imagine reduction in black layer thatch, like the photos show. That's exactly what happens. You're getting, if you have any kind of a thatch or compaction in the top layer, the top inch or 2 inches of your soil profile, that's exactly what OxyTurf is going to address on application. As far as its mode of action, there's going to be a wonderful improvement in the nutrient uptake and sword vigor. We have we're in the horticulture sector. We have a similar product called Oxy Agri, which is used in a number of different plants. One particular group which is using it quite a lot is the horticultural guys farming succulents, which is quite fascinating because one of the ingredients is aloe vera in our product, and it works so effectively in stimulating the vigor, color, health, and disease suppression in the cultivation of these succulents from offcuts right through to full-grown plants. And what we're seeing predominantly, and one of the main reasons why it's used in the sector is in the horticulture sector, is because of its contribution to resistance, ISR and SAR. So from the foliar applications and also what it does to the root resistance, particularly when it comes to fungi, negative fungi and bacterial attacks. It has a wonderful function in the suppression of that disease. Hilary, if you don't mind, just to make yourself put yourself on mute. I can hear a little bit of interference. If you don't mind, just while I'm talking. Right. So one of the wonderful contributions, as I've mentioned in the product, is an enzyme called peroxidase. And peroxidase is something that is found very widely in the plant kingdom, in fact, the animal kingdom as well. It's funnily that's exactly what happens in your hair when your hair turns gray. It's because of the function of peroxidase that actually you don't oxidize incredibly fast, and basically why your hair doesn't fall off immediately, because it's protecting your hair from the byproduct of respiration, where you have hydrogen peroxide being naturally produced, and it's the peroxidase that breaks down the hydrogen peroxide in a manner that doesn't oxidize and isn't volatile and doesn't erode. And this is so incredibly important because what we have in our product is, in having both the peroxidase and the hydrogen peroxide, we now have the ability to provide oxygen in a way that isn't an oxidant, to the extent where, for instance, you can request of us the toxicology reports, and the toxicology reports from both a germination side as well as a water toxins side. There's 0 toxins detectable at the dilution, or the prescribed dilution rate, say 4%. The 0 toxins recorded, and also 100% germination. So in the Zucchini test, they use a very sensitive seed, and then how they determine toxicology is basically how much of the seed germinates under the influence of the product, which ours gave 100% germination, which is profound when it's understood that we have this availability of oxygen in the product. And the availability of hydrogen peroxide, which we all know is volatile and is corrosive and is certainly not good for biological life. It'll wipe it out. So it's what makes this product so incredibly unique. And I'll go through some of the other wonderful contributions that peroxidase performs. Now, auxins, I'm not sure if you're familiar with what an auxin is, but auxins are one of the best growth hormones. Auxins are found in Eclonia maxima kelp seaweed, which is mainly, the one that we distribute is from the west coast of South Africa. And so the peroxidase, one of its main functions is to metabolize this auxin. So it's one thing to have and introduce auxins into your soil profile, but it's another thing to have something that aids in the metabolism of that particular hormone. So, and just to explain what an enzyme is, I mean, just so that you're all on the same page, an enzyme is simply a key that catalyzes a chemical process. So it's something that will basically make something happen a lot faster. So what's happening here is these auxins, which are going to metabolize, be able to be used by the plant, and basically going to, as I'll go further, it's going to now contribute to the building blocks of the plant, which is why it's a growth hormone. Now, lignin and suburin formation, this is basically all about nutrient transportation. Now, peroxidase is a fundamental contribution to this as well. So what we have here is you've got it improving the transportation of water, which is the suburin, but you've also got it improving just the general transportation of water itself, and that's because it's aiding in the cell wall building blocks. So you're just getting basically your pipelines in the plant. improving the strength of the pipelines, but then also it's strengthening. So you're strengthening the roots, and then you're also improving the flow rate. And within that water or with it, whatever the liquid is transferring, you've got all your nutrients. So you're getting better nutrient distribution within the plants. It also acts as a cross-linking of cell wall components, and basically that's just telling you that you're getting better cell wall construction, which is what will help and what will be visible in things like vigor. You'll see that the plant itself, or the sward of the grass, you'll see it just literally standing up, looking stronger. That's where the cross-linking contributes. The phytolexin synthesis, this is another contribution, and that's all got to do with protecting the plant from pathogen attack. And then we have it metabolizes your reactive oxygen species and nitrogen species as well. So, which, without getting too complicated, that's basically just related to preventing oxidation again. And then, yeah, just below, we've got some of the equations of what actually happens depending on what it's reacting with, because it can, with various compounds, there's different reactions, but largely what you're dealing with is the peroxide is being utilized as oxygen and water in a manner that is not oxidative and protected from the volatility of hydrogen peroxide. Now, we've just recently launched the combination of these two products, and that's really because of this top, what I've mentioned at the top there, where it talks about the metabolism of auxins. This was what, because we've had the two products separately, and we just realized, like, this is such an amazing combination product to have them together. So we've got OxyTurf now with 2 liters of organically farmed, cold pressed Eclonia maxima kelp seaweed suspension. I know it sounds like a mouthful, but basically it's kelp, which is, there's absolutely no additives used for extraction. It's simply a cold pressed cell burst technology that's used, and then the liquid is extracted with absolutely no additives, and then only on bottling do we use some citric acid to stabilize the product. Kelp in itself is just an incredible growth stimulant. It's obviously very well known, and this particular kelp from the west coast of South Africa is known for how it grows 0.5 meter per day. That's how much of this growth hormone capacity it actually has. So it's an incredible product in terms of growth, and that's what really, you get all those beautiful kelp forests in South Africa. That's where they come from. You can have a look at the website ukelp.com. So that's that. We have it's obviously got all the wonderful trace elements as well, 17 recorded, and then varying levels of the hormones. Okay, super. That's it from me. Just regarding those two products, I think you can take it away from here.
Thank you, Luke. That was great.
Super.
That was really good. And yes, just to add to Luke's message, that kelp, that seaweed is grown in the cold Benguela current, and that makes a very valuable contribution to the seaweed as well. And as Luke has said, we'll have the seaweed on its own. At this stage in the UK, we are promoting the OxyTurf combination because of the wonderful synergy that we are getting from both products in a single can, which obviously helps you when you're purchasing and when you're storing. and when you're utilizing. Okay, Luke, if we could move on. All right, now we go back to, we're still continuing with the liquid fish. This is, when will this be in, Luke?
Yeah, this will be in 2020. We'll have the combination, but also just straight hydrolysate, which is the lovely thing here is just to understand the difference between the hydrolysate and the emulsion, and how the hydrolysate is really the most or the better of the two in terms of functionality, and for it's because it's been processed naturally already, and you're just taking that extract, and it's just an incredible feed for plants. If not the best natural feeds for plants.
Okay, so this fish hydrolysate we'll have next year, and as the slide indicates, it's a great fungal food. Everybody knows how useful it is, and yeah, we're hoping to offer it to you at a very competitive price. Okay, this is not a time really to spend on product. We're more looking at what and how we can use them. Right, now we pick up again with SAR and ISR, and here we've got a beautiful slide showing us just how it all works. SAR is, as we said earlier, is a long distance signaling mechanism that provides broad spectrum and long lasting resistance to secondary infections throughout the plant. So systemic acquired resistance is something that we're going to be living with for the rest of our productive lives, because it's the most natural way to go. It just makes sense to utilize the plant's own mechanisms, and to utilize bacteria and fungi that are freely available. And also there is so much research and development going into it. And just in the same manner, we can see induced systemic resistance is activated by root colonization with plant growth promoting rhizobacteria, which we discussed earlier. And the induced resistance is effective locally in roots and systemically, via a mobile signal dependent on two phytohormones. So yes, here once again, we are utilizing the plant's natural defense system. Thank you, Luke. Salicylic acid increases the plant's response to tolerance and resistance. And salicylic acid is a whole plant resistance response that occurs following an earlier localized exposure to a pathogen. So yes, we are playing a little bit here in terms of using salicylic acid. Our product comes in the combination of a foliar feed, and we've put the nutrients with it that strengthen its and help strengthen its ability to protect plants. Thank you, Luke. Right, this is one of my long-time friends. I've used this product for close on 30 years, and it's quite interesting, even though there are so many different forms of silicon that are now available. It's very interesting to see that even in agriculture and horticulture, how it's coming back. I think its problem in the past has been that people haven't known how to mix it properly, and it's always been a problem mixing with nitrogen, and we've managed to overcome that now, and have got a mixing procedure which makes it a very effective and cheap way of promoting SAR and ISR. Yes, get in touch with us, and we'll tell you how to use it effectively. Thank you, Luke. Right, now this is a very interesting slide. In my early days, before all the new products became on the market, and as I understand, and as quite widely represented in journals, a plant moves silicon in the form of monosilicic acid. So there has to be this conversion in the soil in order to transport the monosilicic acid through the phloem up into the plant. And what we have here is a lovely graphic showing this cycle. Now, don't be confused by the title, which says natural orthosilicic acid, because natural orthosilicic acid is generally referred to a manufactured form of silicon. So when the microbes and the soil and the compost are doing the conversion for you, it is transported in the plant as monosilicic, but when you spray it chemically, it's in the form of orthosilicic. But in essence, they are both the same chemistry. So it just shows you how wonderful nature is in producing a nutrient and making it available for the plant to transport it. And what is quite incredible is that monosilicic acid is really good at moving calcium through the plant. And we all know of the triumvirate of calcium, boron, and silicon. We all know the wonderful contribution that they make to a plant's defensive system in terms of strengthening cell walls and such like. Thank you, Luke. Right, now we're not going to spend time on product because I see we are running out of time, but just to bear in mind that chitosan is a phytoelicitor and makes a wonderful contribution in adding it to silicon as well. Thank you, Luke. Plant exudates. Now I'm just setting you up for a bit of a promotion, because through plant exudates we get amazing amount of sugars and organic acids entering the root zone, and these plants exudates are generally acidic or mostly acidic, and certain plants produce more acidic exudates than others. For example, fescue grass produces very acidic exudates, which help contribute to the nitrogen cycling and to the fungi developing and improving their degradation of plant organic matter. Thank you, Luke. And as we spoke about earlier in Luke's session, where he spoke and explained to you about the phytoelicitors, what I'm going to add to this is that as you degrade thatch and lignin, you are actually producing even more phytoelicitors, and that's when your peroxidase actually increases, and that peroxidase in turn then increases the degradation and the breaking down of thatch. Thank you, Luke. Right, this slide has purposely been left like this. Here we're talking about diatomaceous earth, and I've left the slide in this raw state to show you what we don't have. So in other words, the diatomaceous earth that we encourage and promote is micronized to minute particle sizes and then put into a suspension so that it can go through your sprayer system. But what is important to understand is where diatomaceous earth comes from and why it has a lasting effect and the wonderful contribution it makes in providing silicon as well. Because as the microbes break it down and as the composting continues in the root zone, so the silicon is made available in the form of monosilicic acid. And the diatomaceous earth with its coarse-shaped diatoms, jagged edges, and its period that it remains in the soil before it's actually broken down, provides a wonderful mechanical barrier to insects and such, as you'll see in the next slide. Thank you, Luke. Diatomaceous earth can be used as a mechanical pesticide, and there you'll see it up in writing. And this has come via obviously through gardening channels and through agricultural channels. And diatomaceous earth has been used for about the last 10 years in a liquid form, in a micronized liquid form in agriculture and turf for a very long time. Okay, thank you, Luke. Just a little reminder of where and how we can get a system that promotes your ISR, your induced systemic resistance. And these are the kind of products and what they do and how they contribute to giving you that. And what we've done, as I said, I like to leave you with an image that helps you remember what we've spoken about before. Thank you, Luke. Right, here we come back to succession and what we're trying to achieve. And through succession, we're talking about taking sports turf surfaces and improving them by encouraging the finer grasses. And in that same paper of 1999, Professor Alan Gange, that is what he set out to prove, that through mycorrhizal inoculation, and the Mycorrhizae was inoculating the bent and the fescue. It does not form a relationship with POA, and through that way, by moving the successional status, the successional species, the fescues and bents thrived and improved. And I'm very privileged to work on one of the golf courses that he did his trial work on, and happy to announce that they have increasing amounts of fescue every year, and they cut their turf at 4.5 millimeters. Their height of cut is 4.5 mil, right the way through the summer, and they produce very, very good surfaces. And they still promote the microbial community, which is a fungal dominant microbial community which promotes the finer grasses. Thank you, Luke. Right. This might be a little bit of a reminder, but it's so important that we remember this, because the soil organic carbon, as we spoke about earlier, is vital to the building up of our soils and the improving. And here we've got an indication of the rate of exudates. Cereals release up to 20 to 30% exudates, pastures 30 to 50. Now you might say, why have we mentioned cereals or pastures? Because the most grown cereal is wheat, and the most grown pasture is ryegrass. And when any trial work is done, scientific trial work is done, wheat is used, and then the information is extrapolated to calculate on how grasses would perform. And of course, pastures cover large areas of the earth, and they are wonderful sequesters of carbon. And in fact, grass can sequester as much carbon, if not more, than trees even do. And it's something which is not taken into enough consideration. Thank you, Luke. We're just going to look at the Moulders chart very briefly. You've all seen it before, but in everything we've discussed today, where we've spoken about nutrition, it's always important to see which nutrients support each other and which nutrients are antagonistic to each other. So always bear that in mind. Get hold of a Moulders chart and study it in your own time. Thank you, Luke. Thank you. Right, nutrient efficiency, and this we will be summarizing at the end as well. And this has been put up to support the use of micronutrients, to support the use of introducing microbes, introducing critters, because what this slide is telling us is that percentages of nitrogen are lost, percentages of phosphorus are lost, and percentages of potassium are lost. And everybody understands why K is lost, because it's a weak cation with a single positive charge. But phosphorus, unfortunately, is a strong anion, so it actually repels clay colloids. But chemical forms of nitrogen are just sadly lost. If you follow what's going on in New Zealand with the polluting of rivers, you'll see the consequences of over and excessive use of nitrogen. And if you've got the nitrogen in the bodies of the microbes, you're at least retaining a larger proportion of it. Thank you, Luke. Thank you, Luke. Right, now how do you save the microbes? Unfortunately, we can't control everybody's use of chemicals and salts. If you go back to webinar 1, you could be it's clearly explained there. But if you are forced to use fertilizers, especially granulars, or even foliars or liquids that have renowned high salt contents, please add a carbon source. And we're going to look at those for you now. Thank you, Luke. Our first slide is going to be humates. No, back, Luke. Okay, now carry on. Carry on. Our first slide is going to bring us to humates. What are humates? Humates are derived from prehistoric plant matter, as we saw in my first slide today, and in a slide that I've used before, a slide which describes the most idyllic situation, probably only now experienced in woodlands and forests of some length of time. But so the humates are a range of products, and the most famous humate is leonardite, which we encourage as well, because leonardite has very little salt and it has a wide range of nutrients. Thank you, Luke. In the humates, we have humic acid, and the beauty of humic acid is that you can get it in an acid form and an alkaline form. And it's a larger size molecule, so it hangs on to nutrient as well. Thank you, Luke. Fulvic acid is the smaller, lower molecular weight than humic acid and is generally always acidic and is a great product to put into your spray tank first for the acidification of your spray water. It's not a genuine buffer, but we experience very high pH waters in the UK and Europe, and the fulvic acid helps beautifully to drop that pH. It's an organic chelator, and it has a wonderful function in terms of carrying other nutrients into the plant. Thank you, Luke. Right, now we come to my favorite, because foliars play a massive role in stimulating exudates, and my critters, my wonderful critters, my hardworking critters, they just need these exudates. They need the sugars, they need the carbon, they need the amino acids that the roots produce. And a good foliar feed linked to a carbon, especially an amide foliar feed, even improves the amount of exudates that a plant produces. Thank you, Luke. And feeding through foliage, the beauty of this is that you can work independently of your soil, and there's greater loss. The plant takes it up within an hour, and within an hour, that plant is already producing exudates, which, as we've spoken about at length today, are so ideal for promoting your biology. Thank you, Luke. How does it all work? How does it all work? You can use such a little bit of foliar feed to produce those sugars and to produce those amino acids to feed the soil microbes. You need so little of it. So this is a great way to reduce the amount of nutrition, amount of fertilizer that you're introducing into the system. And the lower the fertilizer that you introduce into the system, the harder the microbes will work for you. Because even with small amounts of foliar feed, you are producing great amounts of exudates. Thank you, Luke. And here we see the slide which explains it all. And just look at what you're getting. Just look what you're getting out of those foliar applications. You're getting sugars, carbohydrates, proteins, vitamins, phytonutrients. The phytonutrients fall under the bracket of the phytoelicitors that Luke was talking about earlier. And a good balanced foliar feed system acts as a good health deterrent as well. Thank you, Luke. We're just going to run through some nutrients. You can look at this later in your own time. We did mention earlier calcium, boron, and silicon. We'll just look at them again. Calcium, cell wall strength. Boron, sugar translocation. Silicon, cell wall strength. So here you can identify nutrients, which really helps you when you're working with foliar feeds, because you can make a specific tank mix to strengthen your IPM program. To strengthen your IPM program, you can select these particular nutrients. You can fire up your tank. You can stock up your tank to apply these whenever you want to. You're not in the hands of a granular, waiting for it to break down, waiting for rain, waiting for irrigation. You're not in the hands of a granular, hoping that you've got microbes in the soil to break it down, because the nitrogen cycle has to have bacteria to break any granular fertilizer down and make it available to the plant. But with the foliar, you can mix any of these, you can make your cocktail to perform the certain strategy that you need. Thank you, Luke. Disease fighters, we've spoken about this already, but all I want to stress here is that too much nitrate can weaken the plant, lower the bricks, and the plant then loses its ability to fight off disease. Thank you, Luke. Active defense is involving your biochemical pathways, right? These are all designed, the plant is designed to protect itself. And I've seen trials done before where people have left half a green unsprayed, and you can see the difference. That even just the nutrient was helping the plant fight off disease. But where there was no spray applied, that area got a disease quite quickly. Thank you, Luke. Biology, how does it work? How does it prevent disease? What you've got to think about here is a good rugby defense where all the big guys stand on the line and they stop people from getting through. So the main function is the antagonism, the predation, and the competitive exclusion. And that's where you picture the big rugby forwards stopping anybody from getting through or getting into their space. Thank you, Luke. Okay, I've left this for last. There is one more slide to come. I've left this for last just as a gentle reminder that compost teas and brewing actually produce biochemicals that are released into the brew that are antimicrobial and plant growth promoting compounds. Now, yes, this wasn't a compost tea seminar, but I would like you people to just bear in mind that there is a place for compost teas in horticulture as well as in turf. And then we'll conclude with the summary, Luke. Working with biology is not an instant fix. What we have to bear in mind is that your planning has to be at least 3 to 6 months ahead. And this is where OxyTurf is such a great asset and such a great help, because a large percentage of root zones are not compatible for biology. And OxyTurf, kelp, and the humates, the humic and the fulvic, can be used to clean up those root zones. Luke, right before the meeting, gave me some real interesting information, which we're not going to talk about now, but just to whet your appetite, we'll have that information out soon once it's all confirmed. And we've seen clearly how OxyTurf can clean up root zones. Gentlemen, we've run out of time.
Just on that note, as we enter the Q&A now, I can actually show that. I think it will be very valuable for everyone to see. Just to make sure, though, are you complete?
I've just got one last thing.
Okay, please.
Thank you very much for your time. As I said in the last webinar, nothing is taught until it is learnt. And so I apologize if there was repetition, but I wanted to make sure today that those that were seeing these webinars for the first time would be able to catch up on everything that we've dealt with over the 3 webinars. And thank you very much for your time.
Hilary, that was fantastic. Thank you so much. Always, your contribution is just so valuable, and it's wonderful the way that you put everything together in a palatable format. So thank you. That was excellent. Great pictures as well. Great presentation. Right. So I wanted to show you something because I'm in the Netherlands here, and so we've been getting really wonderful results on the football fields and golf courses, and of which there's a company here called the Ink who manages a number of these courses. Two of which, one is the where Ajax plays at the Johan Cruyff Stadium, which we've been getting fantastic results over some time, but most recently it's Vitesse actually, and the lead agronomist that consults for them and helps them formulate their program sent a wonderful video that actually gives you a very clear idea of what OxyTurf can do for the profile. So excuse me if I make a mistake in sharing my screen here, but I think I know how. You'll just need to let me know if everything's working correctly. So and I hope, I'm not sure if you're going to hear the audio, so I'm just going to discuss the audio as I go through this. Are you seeing my screen at the moment? Do you see like 3 vats?
Yes.
Okay, perfect. So these 3 vats are from the Vitesse Football Club, which is a Premier League club in the Netherlands, yeah. And what we wanted to, what they're having a real big problem with water retention. So too much water has been held in the soil, and there's just too much compaction, too much organics, too much thatch, and the water is just not able to run through the profile, and therefore it's turning anaerobic. They're not getting enough oxygen. They're not getting the kind of nutrient uptake that they need. So there's a gentleman called Arno Westhuizen who is the agronomist, the consultant for them, and he sent me this video today. Can you hear that audio or not?
No.
Okay, I'm going to have to walk you through this then. So basically, what you see on the left is the control. On the right is, this is now worked out at 120 liters per hectare, which is very high, by the way. Our standard treatment plan is only 20 liters. But because of the situation, this was actually not by council. This was them just going ahead with this trial because they had such a problem. They wanted to see, how effective it would be if they increase the dosage rate. So they increased the dosage rate to 120 liters per hectare, which is of course 6 times the amount. And then also in the middle, they got 80 liters per hectare, which is 4 times the regular treatment plan. And what we had on the right is a complete flushing within 2 minutes. And that would have been, if I remember correctly, that was 600 liters of 600 liters per hectare in terms of volume. So that would have been your average tank sprayer. This was flushed right through the profile within 2 minutes. This took slightly longer, and what was very interesting is that here we had the liquid flushing right through, but in the middle we have more organics leaching through. So this would actually be cleaning the profile more, because you can see the coloration of the water. On the left, this was taken 16 minutes after after pouring the water in. This is 16 minutes, and you can see that the water level is still not through. It still hasn't leached through on the control. So just showing you how. Let me just show you some more of these pictures. Yeah, that gives you a nice idea. So this is at 16 minutes. Still, there hasn't got all the water through. And there's the 120 minutes that was already completed within 2 minutes. This is again just showing you how the water hasn't gone through in the control. Yeah, that was the control. How everything's gone through with the others. And this is just taking a what do you call it when you take a cylinder cut of your profile?
A plug.
A plug, yeah. Yeah. So that's all I wanted to actually share with you. If you'd like to actually listen to the audio, I'd happily send those videos and photos onto you via WhatsApp, for instance. That's a good mechanism of just sending it around. But yeah, anyway, thank you very much. I think that's all I had to contribute. In general, it's I really would like you to consider using OxyTurf in your programs. It's a wonderful product. It really is, and it's I believe a product of the future, something that's going to be just a wonderful contribution to all turf managers and turf management programs. So something you should have in your arsenal. Anyway, thank you very much. Thank you, Hillary. You've been a superstar. Please send us questions if you have any. Let me see. I didn't. I know that there was actually. Did I answer everyone correctly?
You've answered, Andre.
Okay, perfect,
Yeah.
Andre. Andre, if you'd like to know a little bit more regarding the toxicology, one thing that through all our studies, there's absolutely no negative effect to soil biology when one uses OxyTurf, and that's exactly why we've done that toxicology report to prove the concept, and that is really available on the website. Actually, you can download it if you'd like to see it. But any questions that you have in that regard, we'd be only too happy to share with you. Super. Well, thank you very much, everyone. We've kept you for an hour and a half. I hope you've enjoyed everything, and we hope to see you again in the next one. Okay. Thank you very much. And that's it from me. Goodbye.
Good night. Good night.
Okay. Take care. Bye-bye.